Okay, now let's say x minus x squared plus 3. Okay. So I can look in two places and figure out the degree. I can look at the graph or I can look at the function. Now, if I'm looking at the function, what's the degree? 5, right? But if I go to the actual function itself, what am I looking at to determine? The terms, right? And how many terms are there? 1, 2, 3, 4. And if they're, you always, right, you go up by 1, right? So degree. Next part is the real roots. Where do I find real roots at?
X-axis.
Right, where it actually touches the x-axis. Okay, so there's 1.
That's 2.
Yeah, so what about that one? It bounces and we call it, what's the name of it? What do we call it? Double. So this actually counts as 2. It counts as 2 roots. Now, if you remember from the notes, if the degree is 5, how many possible roots can you have? You can have 5 roots, right? So degree is also how many possible roots you can have. It's the same thing. So as I'm figuring out these roots, I shouldn't have any more than 5, okay? So here I got a double root. Here I have 1 root, a single. Okay, so that's already 3. So then I gotta figure out, okay, well that means there's complex roots. And if I have 3 real roots and the degree is 5, how many possible complex roots can I have? 2, so that's it. Okay. Only have 2 more real roots. So you want to find first how many real roots are there, okay? And then after that, how many complex? Okay. Let's look at. Okay, so that one's a lot like the first one. Okay, but compared to like number 1. Okay, so this is going to be, I'm going to look at number 4. Okay. Again, it's not the exact example, but I'm doing something very similar to it. So let's just say this one. All right, looks like that. All right, now this one doesn't give you a function. Okay, you just have the graph. Okay, so possible roots. How many possible roots? First of all, what's the degree? 3 or 4?
3.
3, right? 1, 2 terms, so 3 possible roots. Okay, so how many real roots? All right, cross through once, so that's a single root. It doesn't bounce. Remember, every time it bounces, it counts as 2. If it only crosses through, it's only 1. Okay, so that leaves how many complex roots?
2.
All right, 2 more. Okay, so start with your real roots, and then whatever's left over, that's going to be your complex roots. Okay. Let's see here. What about that one? 1, 2, 3, 4. 5. Okay, let's actually do 1 more. Turn this over. There we go. Okay, so this one will be a lot like number 3. Okay, so let's say I've got bounces, comes through, comes back through again. 1, 2, 3. Okay, and then comes back through here. Okay, so it crosses through 3 times and bounces. All right, so first of all, Giselle, how many terms?
3.
Okay, 1, 2, 3,
4.
4. So what's the degree or possible roots? 5. Okay. Okay, Giselle Ramos. Okay, so how many real roots do you see here?
4.
How many?
4.
So here, that counts as how many? 1, then 2, then what kind of root is that? So it's a double, so that counts as 2. Because anytime, remember, it bounces off the graph, that counts as 2 roots. So I got 1 here, 1 here, 1 here, plus a double. So how many real roots total? 5. Now, if the degree is 5, how many complex roots possible do I have with them? None. Okay, so you can't go past the degree. Okay, that's your limit. All right. All right, now, so that's looking at a graph. Okay, but then you can see kind of at the bottom, oops, let me move over here. You just can't see over there. Okay, so at the bottom, now we just start looking at functions. Okay, so that's all we got. Okay, so there's a little bit of work involved with some of these. Okay, so let's have x plus 2. Again, this is a lot like number 5. And then let's say I've got 3x squared plus 7x minus 2. Does that work? Or I could go the other way. I gotta go this way. Yeah, okay. So in order to figure out how many roots we have to begin with, okay, we have to know what are the factors for this. In order to know the factors, what do we have to do with this? Because that's a factor right there, but that we've got to break it up. Got to do the box. Okay, so set up my x. What number goes on top? No. Right. That 3x times 2, 3x squared times 2x. I'm sorry, times 2. And then what goes on the bottom? What two numbers multiplied at positive 6 add up to negative 7?
1 and 6.
Okay, 1 and 6.
Both negative.
Both negative, right? I'll set up the box. What goes in the first box? Okay, 3x squared. What goes in the last box? 2. And then what do I put here? Right, and it doesn't matter. I can put negative 6 there. I can put negative 1 there. It doesn't matter. All right, negative 6 is on the bottom. So what goes above? That's where your 3 goes, right? Because that's the common factor. Okay, then straight across, what's the factor here?
1.
Or just 1x. Okay, then x times minus 1, 3 times. So negative 6, negative 2, right? And then check, does negative 1 times negative 2 equal positive 2? Right. All right, so now I can rewrite this with 3x minus 1 and x minus 2. So now the question is, how many real roots and how many complex roots? So first of all, what's the degree of the function?
3.
It's 3. How do we know it's 3?
Because there's no double bounces in it. 1, 1.
All right, so we have 3 roots. There's no square, so there's no double, right? So basically the amount of roots you have is your degree. Okay. All right, so now the next question would be real roots. Okay, so real roots, are these all real roots?
Oh, yeah.
So like what would be the root from here? What number do you get from that? Minus 2, what about that one? Positive 2, you guys know what that one is? It's a fraction, what is it? 1/3. All right, so 3 real roots. How about complex roots? Right. First of all, you don't see any, and the degree is 3, so we can't have more than that. Okay, So that's it. So that one required me to factor a little bit. Okay, now go to the back page. And let's look at, do a couple of those. So, oh, that's good. Yeah. All right. So I got f of x equals, actually, hold on, let me turn the light on. Actually, Karina, can you turn that light on, please? Yes, all of them on. No, other way, other way. There you go. Okay, so x minus 2, then we'll have, so actually, we'll just talk about number 6. So number 6, which is x minus 5 plus 25. Same thing, try to factor that, right? Set up your x, factor it out, see how many roots you have, all right? So it's a lot like the last one. This one, like the next one. All right, actually, let's put like 9 there. Okay, so first, we have to see if we can factor anything. Can I factor x by itself? No. Can I factor x plus 1? Can I factor 9x squared minus 4? You actually can. Okay, and this is one part of the review that I want to go over. This is from week 1 when we did difference of squares, second page of the packet. Okay, so you guys are up front like this. Okay. This page right here, difference of squares. Okay, so difference of squares, remember if I had 2 perfect squares, 9 and 4, and they were being subtracted, okay, I could factor that. Okay, what does that become? What's the first term? 3x in both, and what's the second term? 2. What are the signs? Plus and minus. Okay, so that was the difference of squares. You have 2 perfect squares. All right, so I can split those into 2. So now, x plus 1, okay, and these 2 others. So, first of all, what is the degree? 4. There's a root. What's the root from that? From just x? Not 1. 0. How about this one, x plus 1? What's the root there? It's plus 1, so it's -1, and we do the opposite. Yeah, how about that one? Okay, -2 thirds over 3. So that one's -2 thirds. This one is +2 thirds. Okay, so there's the second question. How many real roots? How many real roots?
3.
No. 4. All of those are roots. Those are all x-intercepts. So this graph goes through there, right? 1, 2, 3, 4, crosses 4 times. That 0 is another real root because it crosses through the middle. I don't know what the graph looks like, but it crosses through 4 times. Okay, so 4 real roots, nothing about those is complex. So then 4 total. Okay, which means for complex roots, how many would we have? None. Okay. All right, let's do one more.
How do we know if it's a complex root?
That's the next one. I'll show you what the next one will kind of paint that picture. All right. Okay, so now let's say I've got f of x, and then x minus, let's say x squared minus 16. Okay, then 2x squared. Well, actually, let's do 9x squared. Sure. Actually, yeah, let's do the same thing like that one. Okay, so 9x squared plus 4 this time. Okay, so first, you gotta say, can I factor x squared minus 16? Yeah, because what number is that?
1.
Is 1 a perfect square? Now, just remember, perfect squares are numbers that I can square root, right? So like, what's the square root of 9?
3.
What's the square root of 4? What's the square root of 16?
4.
What's the square root of 1?
1.
1. So if you can square root it and you get a whole number, that's a perfect square. Okay, so what are these two factors here? X and what?
Positive 4.
Plus and minus 4. Okay, how about that one? Are those perfect squares?
Yeah.
Yeah. Can we factor that?
Yeah.
No. Why not? What's different about that compared to that?
It's a plus.
It's a plus. Remember when we did that method, it's called a difference. You guys remember what difference means? What's difference mean? Minus. So difference of perfect squares. But this is the sum, or sorry, sum of perfect squares. We're adding them. So basically, if it's minus, you can do that. If it's plus, you can't. So that's not factorable. But what comes from that is a complex root. And I can make it look just like this. Okay, so if I was to factor that out, this would end up as 3x plus 2, 3x minus 2. The only difference is that last number will have r when I do that. Okay, so for instance, if I solve this, set it equal to 0, I subtract 4, I'll show you where it comes from, and then I do 9x equals negative 4. Okay, to solve that, okay, what I could do is square root both sides. If I square root that, I get 3x. If I square root that, it's going to be 2 what? I. But remember, when you square root a number, what do I put here?
Plus and minus.
Plus and minus. Okay, so plus and minus. So now, the last thing, last thing I would do is divide by 3. Lost my voice. I get plus and minus 2i over 3, which look, it's just like that. It's the exact same thing, right? It's just there's an I in there now. So basically you can get a root, but you won't get a real root. Okay? So from that, okay, so first of all, what's the degree? How many total roots are there?
4.
There's 4. 1, 2, 3, 4. So the degree is? Okay. How many real roots?
2.
Right? 1 and 2, those are real.
So if it has I, it's a complex.
That is, so anytime you got imaginary numbers, those are your complex. So how many are there?
2.
2. So when you guys have this, like x squared and then plus some number, that's when you know you got a complex root. Okay, so there's one problem on the back of your worksheet, which is like that. Okay, so you can treat this the same way you treat that. Okay, we got 2 perfect squares, and then you can split them. Or you could just know, okay, if I got x squared plus some number, I know I've got 2 complex roots that come from that. So you don't necessarily have to factor that like that. You can just say, okay, if this is an x squared plus some other number, I've got 2 complex roots. Okay. All right, so that should help you guys through that worksheet, and that's what I want you guys to work on right now. Okay. So you guys at home, that's it for today. I'll see y'all tomorrow, unless you guys want help with anything. Same time tomorrow. So see ya.